Hi, my name is Madeline Zidar, and I'm on FRC team 2468.
And I'm Samya Chauhan, and I'm on team 2687.
Today, we're going to be introducing the new REV components. So first, we have the Power Distribution Hub, which is replacing the PDP. And then we have the Pneumatics Hub that's replacing the PCM. And we have the Radio Power Module that is a replacement of the combined PoE injector and the VRM.
So our mentor is Greg McCaskill, who's an NI employee and has tested several control system components ahead of the 2022 season. And Scott McMahon, who is a member of REV's focus group that provides early feedback to REV, both helped us create this presentation. And our team members were able to spend 2 hours with the PDH and did some wire insertion testing with and without ferrules. So what we found is that our 4-gauge wire with our 4-gauge ferrule was not fitting tightly into the port, and the 6-gauge ferrule was not fitting onto the 4-gauge wire. So therefore we will be bare wiring our 4-gauge wire.
We do not know this year's rules and what they would include yet. In some cases, we are speculating, but it is all of our information is based on previous info from REV. The speculation also factors in previous year's rules and similarities to the legacy devices. We do not represent REV. We are just sharing information we've collected from public sources.
So this new control system requires no training for the Wago tool for the PDP anymore because levers are much easier. The RPM takes away some variations in the PoE injector that can be troublesome. Just keep in mind, low-cost PoE injectors bought on Amazon differ in which end gets the power, and getting this backwards could be a problem. There are more ports on the PDH, and there's no fixed positional placement for PDH ports and current sourcings. For instance, if you wanted to connect a 40 amp circuit at the bottom corner, you now can do that.
So the Power Distribution Hub. There are some similarities to the old PDP, but the new aspects to it is that the connectors are activated by levers now. There are now more than 20 ports. We have the high current ports and the low current ports. There's all the different port types. We have different circuit breakers now, the battery voltage indicator at the lower right, and we have LED indication for the circuit breakers. We also use a switch to enable CAN termination, and the size is slightly larger than the PDP. And you get 4 more ports. So we have the PDH to the left and the PDP to the right. So for the ports, we have the battery ports and the high current ports and the low current ports. The battery ports and high current ports are, they have the levers, and the low current ports, you can push down and to lift the wall to insert wires. There's 3 non-switched and then the 1 switch. The fuse is protected, and there's wire sizes for the 12 gauge, the 4 gauge, 18 through 24. We'll get into some each specific port later, but we also have CAN ports. So for the battery ports, it's lever activated, so no tools. The wire sizes range from 4 gauge to 18 gauge fit to the connectors. We would strip the length of the wire to be 3/4 of an inch. You can use ferrules with this board, but only with 6 gauge and smaller diameter wire. So the PDH has these high current ports. There is 20 ports, and they're circuit breaker protected, but the ports can be at any amperage. The wire sizes 12 gauge, and we strip the length with ferrules. The PDH has low current ports and CAN ports as well. There are 4 low current ports, and they all use the same family of the push button connections, and the wire size can range from 18 to 24 gauge wire. We strip the length to 0.35 inches, and ferrules are supported. There is a 50 amp per point limit. The switch port is limited to 10 amp. The low current connectors are protected by ATO size fuses. The expected connections you can use are Robo Rio and the pH, the RPM, and other team applications. To mount the PDH provides 4 mounting holes that can be secured to the robot by using multiple methods: screws, zip ties, hook. We would use the holes to fit a number 10 screw that's 5 millimeter by 0.2 inch diameter. The holes are separated by 4 inches wide and 8.5 inches tall.
So the new circuit breakers, which are actually the same physical size as the legacy ones, but the 40 amp circuit breakers is the exception, which is larger. They are color coded, with the orange representing the 40 amp, the green representing the 30 amp, the yellow representing the 20 amp, and the red representing 10 amp. All high current ports are protected by one of these circuit breakers. These new breakers cost less. And note that the 20 amp and 30 amp breakers you have in stock can still be used, like I said before. And what we and Greg Needle from REV recommend is removing the circuit breakers in a rocking motion to avoid damages, and it also makes it easier to insert and take out. So the Pneumatics Hub, or the PH, which is similar to the PCM, but there are some differences. For similarities, it is CAN connected and controlled. It connects to and controls the same pneumatic components, such as the compressor, the solenoids, and a pressure switch. But some differences include that the solenoid select is a switch rather than a jumper. The PH, as you can see in the picture, is larger than the PCM, but there are more solenoid ports, 16 versus 8. So this means that you would need 2 PCMs to get the same number of ports as the PH. And if you were to use 2 PCMs, you would also need to use another port on the PH to power the second PCM, making the PH just much simpler. The solenoid ports are too small for ferrules, though, so wiring needs to be bare, and it supports REV analog pressure sensors, which are completely optional. So to connect the PH is wired to one of the 3 low current PDH ports and is protected by a fuse, most likely a 15 amp fuse, since the compressor can be up to 15 amps and the maximum current per low current port is also 15 amps. Strip lengths for all wires to the PH is 0.35 inches, and the REV specification recommends using the largest wire size for the power connections to the PDH, which would be 16 gauge. But if you use a ferrule on your wire, that becomes an 18 gauge wire. To mount the PH, there are 4 mounting holes, which can also be secured to the robot in using screws, zip ties, or a hook and loop. You can use a number 10 screw to fit the hole, and the holes are separated by 1.5 inches by 4 inches tall. Now the RPM, which is the radio power module, it's a complete game changer, number 1, and also it's a VRM power supply and PoE injector all in one. This module includes a boost DC to DC converter, and you can use regular 8-wire Ethernet cables. There are 3 connections: the power, Ethernet port for the Wi-Fi radio, which would be yellow, and the Ethernet port for the NI radio, which is blue. To connect the RPM, there is the power, when the PH is wired to one of the 3 low current ports and is protected by a fuse. The Ethernet and an Ethernet cable is connected between Robo-Rio and the port labeled NI Robo-Rio. An Ethernet cable is connected between the radio, the 18 to 24 volt PoE, which is located next to the power jack, and the RPM port, which is labeled Wi-Fi radio. To mount the RPM, there are 2 holes that can be secured to the robot in multiple methods, including screws, zip ties, and hook and loop. The holes fit a number 10 screw, and the holes are separated by 3 inches.
So some practical notes, using these new levers, you need to lift the lever nearly vertical, as you see in the picture to the right. We recommend working out on 1 wire pair at a time when inserting. So lift both red and black wires at the same port, insert both wires at the same time, and then close the levers in unison. Do a pull test and check for any stray strands. We've previously recommended using 2 Wago tools to use for the PDPs. Now you can just use the switch. So for the low current ports, we recommend using a round hex driver to push and not smash the push button.
Also some more practical notes about ferrules. So first, ferrules are thin cylinders of metal crimped to the exposed wire with a little bit of insulation of their own. Different connectors require different crimp shapes. And we use ferrules because they gather all of the stranded wire and present it as a solid wire to the connector. This prevents fraying and stray wire strands that may cause shorts. It also insulates the wire more completely, avoiding the transition from insulated to bare and wire not fully inserted into the connector.
For using the low current and CAN push button connectors, we recommend using a Wago tool, which is like a screwdriver-like tool. To the right, the blade dimensions are 3.5 millimeters wide by 0.5 millimeters thick. So a screwdriver with a blade about 1/8 inch would work as well. There is a small slot to push on the button casting for the blade to match with or to mate with. Push the button down to insert the wire and it will lift the gate.
And also when experimenting with the PDH, we found that the battery wire could be wiggled loose. So in order to improve your robot reliability, we recommend being mindful of your strip lengths because not stripping 0.75 inches of insulation can lead to partial contact inside the connector. The battery wire should be secured 4 to 6 inches from the PDH with zip ties tied to the robot frame.
So a message to the programming teams, the factory CAN ID for REV devices is 1, whereas for CTRE is 0. So a CAN ID of 0 is not supported by REV. All of the new REV components also have USB-C connectors, which simplifies the troubleshooting, setup, and configuration in firmware updates. So the USB-C provides power test and configure.
So what will we be doing? Well, our Team Appreciate, which is Team 2468, and Apprentice, Team 2687, will be using the new REV components, but Team Alpha 2689 will be using the legacy CTRE components. This is primarily to use our existing inventory and not experiment with too many new things. We will be using 4-gauge wire with SB120 connectors for our battery connection, and we will not be using any ferrules on the battery connection, but we'll be using ferrules on the high and low current ports as well as on CAN. To avoid possible wire fraying on insertion, we will insert the wire into the battery terminals before we mount the PDH to the robot.
So,
this is the PH right here. That's how it looks. As you can see, it's much different.
you explain the different ports. Okay. So we have the low current ports that connect to the PDH here, and we also have the CAN ports.
This is the radio power module, and as you can see, this is where the NI right there. I don't know if you can see that's the NI Robo Rio connection, and right there is the Wi-Fi radio connection.
Here is our new PDH. It's very cool. We have now the 20 ports for 12-gauge wire. See, this is where we show how they fit in. You have to just vertically lift the lever up like that, and we will lift it all the way up, and it makes a click noise when it's secure. We also have the circuit breaker, and we have the low current ports here and the CAN ports. And again, when you use the circuit breaker, you have to remove and place in a wiggle motion. Also, inside of the circuit breaker inserts, there is a wall and then 2 metal pieces. So you have to make sure you carefully put the circuit breaker in between the metal pieces and the wall, so you can then begin wiggling it. So it's pretty cool. And again, the battery ports are there. And
we will also right there, because our 4-gauge ferrules aren't fitting, we are going to be bare wiring into the battery ports.
yes. All right. Thank you all for listening.
Thank you.